Okay, so let's take a look back at what we looked at yesterday. Right, we were creating an interface that tried to implement or represent durations, right? And we considered an implementation of using minutes, hours, seconds, and we also looked at several constructors that we were considering. One that would take all the arguments, right? Hours, minutes, and seconds. We also consider another constructor that might take just a numeric value, right? Since sometimes we want to think about durations as just the seconds, right? The smallest amount of interval that we can think of. Today we're going to look at other aspects of that we are faced with many times. Is that somebody might be using an interface. They've already created some code that uses that interface, and somewhere down the line, we revisit our design and says, "Ooh, what if I wanted to have it implemented some other way or some other implementation? What do I do? Right? What do I do with all these clients that might already have committed to having used one particular implementation, right? But I want to add a completely different interpretation of the same concept, right? How can we design our code to be the least affected by these kinds of modifications or refactoring? How can we decouple the whatever implementation we might have or uses of those implementations in such a way to minimize disruption, right? As we go forward and discover new ways to represent things, right? Right. So once we came up with a particular implementation that uses hours, minutes, and seconds, we might decide that perhaps a better representation is just to use the seconds, right? And just have a constructor that you represented internally, that a class that you represent the duration internally as just the seconds, right? And forget about having to deal with hours, minutes, and seconds, and decide that that's only a convenient way of consuming or representing it for human consumption, right? Really, the raw data should just be the seconds, right? And any other representation as hours, minutes, and seconds is not fundamental to the time duration. It's only a convenient way of consuming it. Make sense? Right? So let's consider a completely different implementation, and we'll call it compact duration, right? A compact implementation of the duration idea. Right? We already looked at yesterday the non-compact, the expanded implementation yesterday. Let's look at a compact implementation. So we want the whole point here that we're trying to see how, now that we're going to look at a different implementation, how can we minimize, right, everybody else that is now dependent on our source code. They're already compiling this against this old interface. How can we minimize any changes to those folks that might already have committed to those implementations? So we'll apply a couple of principles that we've been peddling here, right? With information hiding, obviously, we'll still do private versus public. But also, we're going to take a look at another technique, right, of using interface polymorphism, right, where you could have perhaps two versions of the same interface, right, that you might have two different classes that might inherit from the same interface, right, but have different implementations. So let's take a look at these two techniques. So obviously, information hiding, right? We did the good choice of declaring all the fields to be private, which is great. Right? Any client code that is dependent on our implementation had no direct access to any of the fields, which is good. Right? There's no way that it is dependent in any way on internal representations of any data structures inside of our implementations, which is good. Right? That means that we're free to change things internally because the client code. There's no way that it could have committed to anything internally. So that's great. We made a good choice at hiding that. If there's two ways that we could go here. We could say, oh, you know what? I'm going to revisit this implementation. It was a bad idea to have broken up the time duration in this hour, minutes, and seconds. Right? That's only for human consumption. It's really not a fundamental meaning of the concept of duration, right? So I could go and just replace all my implementation on the existing implementation. I could go that way, and that would be fine, right? Obviously, all the client code that is compiling against my implementation would not be affected, right? Nothing would change, obviously. So that's one way that we could go. It would be a legitimate way that we could go, right? Because we have successfully followed the information hiding principle. We could go that way. Another way that we could consider is to, if we're not 100% sure that, what we did was terrible, right? And what was I thinking when I broke up duration into hours, minutes, and seconds? We're not quite sure, and maybe we can keep it around and says, okay, well, I'm just going to leave that implementation. It seemed like a good idea. Maybe perhaps I'm going to keep it. It's still convenient. So I'm not quite sure. I'm not going to throw it away. Instead, I want to just have a different implementation, okay? And have clients select a choice on whether keep the old implementation, right, and compile against that, or they might choose perhaps this alternative representation, right? Perhaps we have we're representing time or a calendar as a Gregorian calendar or as a lunar calendar, and perhaps there's no particular preference, and depending on what your culture might be, you might prefer to go lunar or you might prefer to go Gregorian. And it's just a choice of culture and whatnot. So instead of throwing away our old implementation, we'll just keep it around, and instead we're gonna just create an entirely new implementation. They're gonna sit side by side, right? They're gonna be siblings. They're both gonna inherit from the same interface, but it'll have a completely different internal structure, right? Instead of breaking up the time in hours, minutes, and seconds, it'll just have a long variable declared as long, right, and just keep the time in its smallest representation, right? And see where we go from there. And we're going to call this technique is interface polymorphism, right? Meaning we're going to have one parent interface, and we're going to have two implementations that inherit from this top interface. Yes?
In this compact duration, are you going to be making like a whole new constructor, or are you just going
Yep.
to be modifying it?
No, it'll be a completely different constructor. Yep, the whole thing. Yes. So here's what we're considering doing, right? So here's we have a base interface, right? And we are inheriting. We have our old original implementation, the duration implementation, right? Declaring all these public functions. This is the public interface to this implementation, and it's implementing, many of the duration interface functions, such as compare to, plus, as HMS, and in seconds, right? We have those implementation plus, so some of the domain methods, right, and some of the standard methods that we are inheriting because we're comparable and whatnot. So we're going to keep that around, and we're just going to consider the fact that we want an alternate representation, right? We have a compact duration where we're not going to bother breaking it up into hours, minutes, and seconds. That kind of gave us opened us up to considering two different values that actually had to be represented the same way, right? An hour and 30 minutes is the same thing as 90 minutes, right? So it was kind of awkward having to make those kinds of comparisons and whatnot. So this is kind of took us towards some awkward edge cases that we had to resolve, right? But if we instead decide on some fundamental representation, such as just the seconds, then perhaps this might be a better choice. So let's see where this takes us, all right? Of having two different implementations of the same interface. Very, very common. Now, obviously, if the code that is using our implementation, as much as any client code that stuck to in their code stuck to just the interface, right? Probably they were not going to be affected too much, right? If it wasn't assuming anything about the duration implementation, then those folks are going to be fine. If instead you're going to have clients that deliberately were compiling their code against this particular implementation, then those clients, that code is going to be affected, right? If we need to make any changes. So let's take a look at before that, everybody okay with class diagrams? Just boxes declaring the structure of a data structure, right? That in particular just implements, right? We have the dashed lines here that as opposed to the solid lines, this is it's implementing the interface. Whereas if we were solid, it would be extending, right? A parent class. Also the meaning of these accessors, right? This is public, plus is public, minus is private, and hash is protected. Yes, everybody good? And you have the declaration of the data types and whatnot. And we'll have more of this as we progress through the semester. Also, just one other thing here is that notice that we have the interface is in italic, right, and it has the pointy brackets, right, as declaring as an interface. And same thing for abstract. Abstract is also going to be use the same notation, right. Right, as I was mentioning earlier, right. So if you're going to have some clients, some code that was compiling against the interface, and those we're going to call the happy clients, right? They're going to be affected the least. So if you change anything internally or any interface or anything, their code is not going to be bothered too much, right? If all their code is implemented against the interface. If instead you're going to have clients that are using a direct particular implementation, then that's going to be those are going to be mostly affected, right? So examples of I guess for those who have taken databases, right? If you compile against any one of the interfaces, connections, statements, and whatnot, those are all interfaces. But if you compile against a particular vendor like MySQL or Oracle or any particular vendor that also implements that interface, but instead of compiling against the interface, you compile against the implementation, then you are tightly coupled to that particular implementation. If ever you change the underlying vendor, then you're stuck, right? Your code is no longer working right? You would need to go in and fix all your implementation, and you'd be a very unhappy client, right? If ever that implementation changes. So we would try to avoid as much as possible, right? Being tightly coupled to any one particular implementation. So let's talk about some of the considerations of how is it that we would implement some of this. One of the things that we're going to point out all throughout the lecture is that we're going to see some code duplicity, right? That when we're implementing this new compact duration, we'll see that some of the code, not all of it, but some of the code, it will be very, very similar across these two, right? And I want you to be keen about that and start balking at that immediately whenever we see duplicity, anything that looks similar, right, or identical. Immediately a flag should raise, right? Immediately that to say, "Ooh, something's wrong." We often say that redundancy. Whenever you have redundancy in any system, it leads or breeds inconsistencies, right? Whenever you have redundancy, it breeds inconsistency, right? If you have two pieces of code that look identical and it's supposed to be identical and supposed to do the same thing, right? Whenever you have the duplicity, it might work fine at the beginning, but over time, when a couple of weeks later or maybe even a year later, whenever somebody has to maintain this code and they want to make a tweak, they might have forgotten the fact that these two pieces of code were supposed to do the same thing, and they might update one but not update the other, right? And that starts to create inconsistency across the system over time. So whenever possible, we're going to have a mantra throughout the not only here in this class but even throughout the industry. The mantra is reduce or eliminate any redundancy in the system. Okay, have single points of maintenance, single points of control as much as possible. So we're gonna have lots of examples of those throughout. Right. So unhappy clients, right? They inadvertently or by design they started using a specific implementation of that interface. And if there's any changes, if they want to use the new implementation, right, for instance, a compact duration, because it's faster, because the implementation is much more efficient, it's less memory intensive, whatever. Okay, they've all the new forums are saying, oh wow, this implementation of 3D transformations is so much faster. It uses many more frames per second, yada yada yada. But if your code already committed to a particular implementation, right, you're going to be very unhappy to go on to a brand new implementation, because you're going to have to change every reference in your code to a specific implementation. You're going to have to change it, right, to compact or something else. So ideally, the unhappy client would have instead written their code in terms of the interface as opposed to the implementation. And then at some point up high in the decision hierarchy, the happy client would have had to decide, well, which one do you want to use? Do you want to use this implementation or that other implementation? And then everything else downstream would use that particular implementation, but coded in terms of the interface. So yeah, so these are examples of strong coupling, right, where a piece of code is tightly coupled with a particular implementation, which we aim to minimize, right? We aim to reduce any dependencies. It can't be eliminated entirely, right? It's impossible to entirely decouple two systems. At some point, they do need to talk to each other and know about each other. But at least we can put it in a particular place where is a single place where we decide which one you want to use. At some point, somebody needs to be instantiated. An actual class needs to be instantiated. Yes?
Is there anything you can do to like help prevent this unhappy client other than telling them implement through the interface? Or if they do that, are they kind of just like shooting themselves?
Well, we'll see a technique called the factory design pattern, right, where you delegate that decision downstream, and depending on the particular use case or particular certain parameters that you pass in, somebody decides that this is the best choice for your particular implementation, right? And so we remove the decision from the client at all, right? This says, okay, somebody is upstream is going to make the executive decision that this is the implementation I'm getting. Right? Just pass me something that implements this interface. It's not in my hands to decide who does it, right? So yeah, so we make it upstream, and this has become a very popular, especially in Java, C#, and these component technologies, right, where you have like inversion of control, injection, where you configure all these things perhaps in configuration files, in XML files, not even in the code. There's nowhere in the code that you decide what particular implementation, but even outside of the code, you configure using web.xml or whatever configuration file, and says, ooh, inject this into that client, and the client is just expecting some interface. It has no idea what implementation is getting at runtime, right? So only at runtime you decide, what is it that is going to be injected. Yeah, excellent. All right, the happy client instead made the wise decision not to be tightly coupled. Nowhere does it show in their source code that they're using any particular implementation. It's not even aware that a DurationImpl even exists. All right. Obviously, somebody is going to have to pass it. Somebody's going to have to instantiate it. Whatever mechanism we decide, somebody's going to have to instantiate it and pass it an instance. So somebody does have to be coupled. Somebody has to be coupled somehow. But the interface, the client itself doesn't have anywhere in its source code any references to the DurationImpl. So if you want to instead wants to use the compact duration, that's fine, totally fine. Right? You can pass an instance of the compact duration, and the happy client couldn't care less. All right? And that's where we want to go towards. Right. So we're saying that all our references inside of the happy client are to the duration interface. Right. Nowhere do we have the DurationImpl anywhere. So the benefits of having these two implementations inheriting from this top level interface, right? We're now free to pass around either instance as long as they implement the same interface and pass it around to happy client and other folks who are not tightly coupled with any particular implementation. Yeah, as reality, as Summer was pointing out, in reality, we can't eliminate decoupling entirely. At some point, somebody has to decide what actual instances are you passing around, right? If you're using Oracle or you're using MySQL or using whatever vendor, somebody has to actually decide, well, which one is it, right? Somebody has to make a decision and say, well, it's this particular URL connection. The server is running over there, is pointing to that port over there. So somebody has to physically make a decision on what actually you're using. But as much as we can centralize those decisions into some manageable format and say, okay, well, those decisions are made here, right? And they're not spread across my entire source code, right? And so I can easily manage this single point, sometimes referred to as a single point of maintenance, right? There's only one place that I have to go and configure that, right? And it's not, that decision is not spread across multiple artifacts, Java files and whatnot, right? So yeah, so it's unavoidable, but even though it's unavoidable, right, we can reduce it and make it manageable, going forward. Okay. All right, so let's talk about the actual implementation.